Good morning. Let's get started. So today I'm going to talk to you guys about something very familiar. I think many of you guys know what is React Native is. But today I'm going to talk about what are the new developments in the new version of React Native. This is somewhat of a major upgrade regarding the previous versions. So there are a couple of new and very interesting things new about this version. So let's see what's new. So before we talk about what's new in React Native, we should have a proper understanding about how React Native works. So basically, there are three threads that interact with each other in React Native. So there's a JS bundle. That is where we write our code in JavaScript and we can customize our components and everything we need to in that JS bundle. Then there's the native UI, which is display the changes that we made in JS bundle after the compilation. Then there's a thread called shadow. That is where the application determines what are the dimensions, the styling and everything. It will scan the device, scan the code, and then after match those two together with the stylings and dimensions. So when we write code in JS bundle, usually what happens is it cannot talk to the native UI directly. So therefore, it uses something called bridge. Bridge is where it takes all the information from the JS bundle, then after pass on that information in a way that native UI can understand. So that is the main thing that bridge is doing. So this is the existing way that React Native works. And when bridge passes information through the native UI, serialize all the information as a JSON, then after deserialize it and pass it to native UI. This is not a bad solution for this issue, but bridge is simply how bridge work is all code that developers write in the JS bundle moves into the bridge. Then the bridge passes on that data into native bundle, make the change necessary for application. So it's not like standalone very effective process because we have to serialize it, then after deserialize it when we passes. So in new version of the React Native, the team has introduced something new which is going to replace bridge. It's called JavaScript interface, or else also known as JSI. JSI does not require serialization, and more importantly it's written in C++. So simply JSI will do the exact thing that bridge used to do, but in more efficient way. It doesn't require the serialization and deserialization process, so it can pass on information as quickly as it receives. Also, the next very important thing here is like the information that we captured and the processing part runs very smoothly because the JSI is written in C++. So previously we usually engines to do that, but in JSI we have a C++ background, therefore the processing part is very efficient. So JSI, JavaScript interface, it is completely decoupled from the JavaScript engine. So as we know, React Native run on their own engine. Also, like it interacts with the V8 engine also, which uses in Node environment. But JSI, it completely separated from the React Native engine. Therefore, we can interact many other engines if we needed to when we run React Native application. For an example, we can use V8 engine, which is used in Node environments in React Native applications. In more examples, we can use some new engines like Chakra or few more popular engines with JSI. And since we can use multiple engines with this, it opens lots of doors to the environment. So I think many of you guys know that Flutter has opened up to application development in Windows applications. So with these engine changes and when we can add multiple engines to our React Native applications, which means we can interact with the Windows API, we can interact with any other custom APIs, and we can access their native values, native components, and we can manage to retrieve information from them. Also, this can be used to branch out our applications into different devices. Usually React Native applications runs on mobile devices such as mobile phone or tablet, but in the long run these React Native applications can be used in smart devices such as smartwatches, smart TVs, and any other smart devices that we want. This is the main thing that JSI introduces with their C++ background. So next thing is we use in React Native everything moves on asynchronously. So entire platform runs in asynchronous operations, and the common conception of synchronization is bad and asynchronization is good. That is what developers and everybody thought when they started coding in React Native. This comes out, but it is not the case. So synchronization is not 100% bad and asynchronization is not 100% good. So there's a middle ground. Sometimes we have to prioritize our operation, and sometimes we can run smoothly with our asynchronous operations. So for this case, existing React Native applications use shadow threads to render the UI components and pass on the information to native UI. Simply, in this case, for an example, let's say we use this syntax in React Native, which means we are holding references in the DOM element into JavaScript. So this is not something that React Native is supposed to do, but we can do this because JavaScript allows us to do that. But in new version, we don't have to do this. There's a fabric which is going to replace the shadow thread, which is gonna provide solution for these questions. So shadow thread is responsible for the calculating layout dimensions and positions, and it generates a host view tree. If you guys have some experience developing React Native applications, when we render UI components, let's say we render something like flat list. When we render something like that, what happens is when we display a flat list, we have to scroll through the flat list to view more information. So in this case, usually in shadow, we cannot refresh it enough, and we cannot refresh it faster in order to make a smooth transition when it's scrolling. Therefore, there can be frame drops when scrolls, and it's very annoying and it's not smooth when we pass on scrolling like that. But with the use of JSI, we can capture native elements of the application, and we can capture native elements of the devices into our React Native applications, which means, simply put, we are passing our application through a JSI, which is written in C++. So C++ means we can access our root code and root features, which means native features that are in the device, and associate them in our application. So for an example, for this issue in Fabric, the new replacement for shadow, it provides we can access the refresh rate from our device, and we can refresh our application according to the refresh rate. So which means some devices can have 60 FPS, which means 60 frames per second refresh rates, and some devices can have something more faster, something like 120 FPS. So according to that FPS level in the device capabilities, we can customize, and we will automatically allocate the necessary resources needed, and it will process the information accordingly rather than waiting for everything to load when we scrolls. So it will pass on information asynchronously, but it will prioritize some processes when we run some things like scoring or when we tapping and situations like that. All this is possible because we are using a JavaScript interface, also known as JSI, because it uses C++ based environment for this. So these are the main two things that we can understand in new version of React Native. First thing is JavaScript interface, JSI, which replaces the bridge. And the second thing is an outcome of the JSI, the fabric, which is going to replace shadow thread in JavaScript in React Native. But there's something more interesting in here. In early cases, previously in React Native versions, what we usually do is, let's say we are using some native functions, native features, like we want to use services that our device had to offer, some things like Bluetooth or some things like location services or some other service. So what React Native used to do was, when we open our application, it loads up everything together when the application booting up. So it takes a lot of time, takes a lot of processing power, and that means it leads to more complexity in our application. It's not very effective and it's not very efficient. So as JSI provides some solutions to shadow, as such, it introduces a new service called Turbo, which means simply, as I talked to you guys before, like JSI is written in C++, which means it can access the native features in the device itself. So we don't have to pass on all the elements together to the application. Simply, JSI will provide a service called Turbo, and it will keep a reference of each service available in the device. So let's say we have Bluetooth, location, and some other more. So it will simply keep a reference in our application. Okay, this device has Bluetooth, this device has location service, and we can use it. So it doesn't load everything up into the application when it booting up. It's simply keeping that reference. When the user required us to use certain service in the application, when it comes up in the requirement, then only it boots up and then we can use it, rather than booting up everything when start and then after compiling the application. So this is something very major in perspective to speed and responsiveness in React Native applications. And I think this is going to be something very interesting to see how this is going to play out. All right. So these are the main three things that new with React Native. And even though these things are very new and very flashy, but there are some certain concerns. So basically, mainly in community and React Native team and the React Native community already provide some answers to these concerns, but still some developers have some very famous developers have some concerns in their agenda. So what they provide as a concern is, first thing is, like, since we are using C++ based engine, C++ based platform in JSI, how it is gonna be presented, which means we usually write code in JavaScript, which means we don't have to define any variables or anything. Simply we can pass on information as it goes. But since it is in C++ and the types are defined, some people have the question of, we might have to use TypeScript kind of situation or TypeScript for this, or some sort of a solution of TypeScript. But React Native provides some valid answers for these things. So what they provide was, like, it works as a code gen solution, which means, like, we can simply write our code in JavaScript. We don't have to worry about other platforms and environments and how the thing works. But in behind, it will associate the necessary things that we need to, and it will transform that information that we written in JavaScript into the necessary parts. It can be either TypeScript or some other solution which will introduce in future versions. And this is what I want you guys to talk to you about today. So I hope this is something very interesting to all of you guys, and I hope you guys heard something new and got some interest in the situation. So that's pretty much it. Thank you so much for all of you to join today, and hope you guys learned something new. Thank you.